So, this is my attempt to explain proof of work. And a lot of people are confused about proof of work. And I've tried to use this example before, and it's almost always in response to Keir trying to explain proof of work. And what I attempt to do is show you something really similar, like a baby proof of work that doesn't actually work very well. But let's go for it. And I'm working in my really my favorite environment, I would say, which is the shell, the Unix shell. However, I'm sort of moving away from this. The reason why this is my favorite environment is because of how quickly you can do things. For example, right here, we see I have created a function in the shell just by simply typing it into the shell, and then this command brings it back. And what the function does is it takes an input as 1 and it finds this checksum, this CRC checksum, which is similar to a hash, which is part of the proof of work game or puzzle that they play. Uh, and and then it and then this part here simply is a shorthand way for me to discard the second character. There's other ways to do it, but I'm sort of lazy and just simply do it this way. And so you come up with the first number of this sum, and then I put this function itself into a loop. So while true, which means until I stop it, I'm going to take the value of my sum and kind of loop it through here. I'm going to add a little zero to the end, which is what you see here, which is just a trick to let me make all the zeros colored but still show you a line like this that doesn't have a zero in it, um, using this grep command. So lots of little tricks here. Sleep means to sleep for 1 second. And this thing is this doesn't take hardly any power at all, whereas the real proof of work of Bitcoin takes an enormous amount of power, deals with much larger numbers, and is much better. In fact, you'll see the error in this, and that's okay. That's all part of the fun here. Okay, you guys ready to go? So I hit go, and this thing starts, and you see it's just spitting out numbers. And again, all the zeros are green. Now look at here. You see these? I think this is the winner. 00059 in this little system. And so the miners would say, oh, well, there was one that was 62 that's about to disappear here, but 59 seems to be the winner. And then at some point, they build the block. Now, instead of building the block, the whole thing repeats because it's on a loop. Just ended up that way. So there you go. So 59 is the winner. And of course, in the real world of blockchain, you wouldn't, in Bitcoin proof of work, you wouldn't have this simple error. But again, this is how it works. Now let's try to bump it up a notch. Okay, guys, I'm going to hit Control C, hit up arrow, and I'm going to pull up my function that I created before. Just in the, let's see, let's find it. And oh, this was the example I had before. That was this. So this is an example that I just sort of dummied up, using kind of the same thing. But let's see. It was called My Fun, I think. My Sum, maybe. Was it? My Sum. And I sort of make mistakes. I do that on purpose. I do that on purpose to make you guys, to make this feel more accessible. Okay, so we're going to say my sum. I'm just going to go ahead and retype it. And then, see, I get this second thing here. I'm going to echo the input, and this time I'm going to say checksum. Still with my same while read AB trick, just because I can type it in so darn fast. While read AB, what next? I'm going to do something. Do what? Echo only A. And then I'm done. But why is it not? Well, I have to close my function with this right here. There you go. Now I have changed my sum, and let's just see if we do this now. It's got the same name, but it's a slightly more advanced command. We should see some bigger numbers. So I'm just gonna go for it. This is real time. Are you guys having fun? Sure you are. Okay, so here we go. Let's try this. I have no idea if this is gonna work or not. Boom. Okay, see, we get a bigger numbers now, right? And these don't have the leading zeros like the other one. The other one would print the zeros at the beginning. These aren't going to print the zeros, so that makes the whole I'm going to show you the zeros in green sort of useless. But now we're just going for the length of the thing, right? So you know what? To make this less confusing, again, having fun, we're going to just take this part off and that part off. We don't need any of that. And we're going to go again. Boom. Okay. So you see, so now, so far, this number is the winner. Why? Because it's the shortest. That's the same as having the randomly having a zero at the beginning is to be short. You're not seeing the zero at the beginning. And of course, I could add it back, but you guys can visualize that, right? You know, and so in this universe, you're going to end up sometimes with a really, really short number. And that's going to be the winner. That's proof of work, right? You might have a number that's only that long or something, It's kind of moving on me. But again, here, I'll stop it. I'll just stop it. See this just on what I see on the screen, it looks like this guy right here is the winner. It's the shortest number, and this is not random. This is hashes, or these simple baby hashes, which is before a hash you had these commands sum and checksum, and then its big brother checksum. And I did a lot of work with these, so I'm very familiar with these. And I hope that this was a helpful example in truly understanding proof of work, right? And again, this is still much smaller than a Bitcoin number. It takes much less energy, but that's the idea. All right, thanks.